Hey, polar bears, polar cubs. Let's talk about gases, and then we're going to talk a little bit about Dalton's law of partial pressures. So, first thing that we want to kind of talk about is what is a force when it comes to gases? Or what is pressure? Force is what pressure is per unit of area. So, if you take a lot of force and you put it over a tiny area, you're going to have a lot of pressure. And we can talk about that, and we can also talk later on with how temperature, volume, and even the number of molecules present can affect pressure. So the question initially is, if you have the um, same person, but they're going to walk on tiptoes or on snowshoes, why can someone on snowshoes walk easier in the snow? Well, the answer to that is there is far less pressure. So when they have snowshoes, you have this very wide, base to kind of spread that pressure out or that force of your foot. When you're on your tippy toes, you have this little tiny area, and that is why the pressure is different depending on what you're walking on when it comes to the snow. When we talk about pressure in chemistry, we're talking about four different types of units. We're talking about kilopascals, millimeters of mercury, torr, or atmospheres. These would be your conversion factors, and we can talk a little bit about how we can convert from one unit to the next. So let's walk through one of those. Right now, we're going to put the given over 1. That's 0.830 ATM. Stands for atmospheres, over 1 times. Now, we're trying to get to millimeters of mercury, so it's going to go up top, 760 millimeters of mercury over 1 atmosphere. We're going to multiply that across, and you're going to get 3 sig figs because our given was in 3. That would be 631 millimeters of mercury. So then some questions to kind of just think about before we go into the next slide is, what's the average pressure at 0 degrees Celsius at sea level? And the answer to that is 1.00 ATM, or any of those pressures from up top. So 760 torr, 760 millimeters mercury, or 101.325 kilopascals. So then what happens if I go above sea level? What if I go into the mountains? Will there be more atmospheric pressure or less atmospheric pressure? Well, it decreases. Decreases atmospheric pressure. And if you think about it, above you when you go up the mountains is less atmosphere pushing down. So if there's less atmosphere pushing down, there's got to be less pressure overall. So how do you combat that when it comes to cooking? Because we use pressure when we're cooking quite often, or pressure affects what we're cooking quite often. So the answer, how does something boil? Well, the atmospheric pressure so that pressure is equal to or greater than the vapor pressure of the liquid, or the liquid's vapor pressure. So, let's talk about boiling points. Will the boiling point be higher or lower in the mountains? Pressure is lower, so therefore the boiling point would be lower. Lower atmospheric pressure equals a lower boiling point. This is why in like Denver, Colorado, and higher up in the mountains, water, it boils anywhere from like 92 degrees Celsius to about 95 degrees Celsius. Whereas when you're at sea level, which we're slightly above, um, you boil right at 100 degrees Celsius. So, what would happen inside of a pressure cooker? Well, pressure builds up within it. So, as the water starts to kind of vaporize or evaporate, you kind of create your own atmosphere. Well, you can create as much pressure in there as possible, which then really increases the boiling point of that water. So, due to high pressure, boiling point increases. So I use an Instapot at home all the time, and it's a pressure cooker. As long as you have the valve closed, it builds up pressure, and then when you're done cooking and you want to release the pressure, you release the pressure, and a bunch of steam comes out. Well, when you open it, it's fully cooked, and it cooks it rather quickly and makes it super tender. Okay. So finally, again, if you increase boiling point, you reduce time. So higher cooking temperature, cook temp is equal to faster dinner. And let's all be, honest. Sometimes we're in a hurry and we need that dinner pretty darn fast. So back in the olden days, when dinosaurs roamed the earth and we were trying to find pressure, they used something called a barometer. These are still used in some sense, but they have kind of updated with new technology and things like that. The old barometers used to be a pool of mercury and then a tube, a very slender tube that it would move up. Well, it would move up in millimeter increments. So that's where we got the term millimeters of mercury. It was actually from true millimeters of mercury. Okay. So if low atmospheric pressure, okay, what happens to the mercury? Well, if it's low, there's not enough pressure pushing it into the tube, so more in the bowl. And then if you're using water, which is less dense than mercury, how would this change your barometer? Well, if it's less dense, it's going to move up the column faster. So, less dense equals a higher level. Higher level due to low density. All right. So now that we've kind of discussed pressure enough, let's talk about Dalton's law of partial pressure. So, what Dalton found was that if you knew the pressures of different gases and you put those gases all together, you then should know the pressure of them combined. Or if you put gases together and then you slowly took individual ones out, you'd be able to find the pressures of each one individually. And what they did was PT, which is pressure total, is equal to the pressures added up. So we can do this very easily Now, the guess method, you're more than welcome to use it. It's just the givens, the unknown, the equation, substitute, and solve. As long as you're showing me work in a well organized manner, that's okay. If you need a method in order to do your work, guess is a great one for you. So we have PT 2.37. We got a P. I'm going to use 1 for hydrogen, and that is 0.962. We have a P2 for oxygen, which is 0.705, and we're trying to find P3, which would be for nitrogen. So I don't know what that is, but the units would be the same units from the other ones, so that's atmospheres. So then PT is equal to P1 plus P2 plus P3. This is the only gas law that we will go over that you have to do some subtraction. So since we're trying to solve for P3, we want to get it by itself. So we're going to subtract P1 and we're going to subtract P2. This gives us P3 is equal to PT. I'm going to put it minus the quantity of P1 plus P2. The reason I do this is sometimes in our calculators it's easier to add them and then subtract it out of the total because it does some funky things. So we're going to substitute those numbers in, and when you do that, you take 2.37 and you're going to subtract the sum of 0.962 and 0.705, and you will get P3, which is of nitrogen, to be 0.70 atm. Now you might go, Mr. Day, all of those pressures that we were given had 3 sig figs in it. Yes, but when you're adding and subtracting, you go to the least past the decimal. And since this one only had 2 past the decimal, our final answer can only have 2 past the decimal. Finally, one of the things that we're able to do due to the fact that we know the vapor pressure of water so well is we're able to find, the vapor pressure of dry gas or of other gases that we collect over water. And on our periodic table, on the back, in the lower left-hand corner, there is a little chart that tells us vapor pressures of water. So if you look at 21, you'll find that the vapor pressure of water is 18.65 millimeters of mercury. So this is the P total. This is P1, and we're trying to find P2. Well, in order to find P2, what you're going to do is you're going to take PT minus P1, and you're going to find P2. So when you plug in those numbers, you have 739.6 minus 18.65. And you might look at those and say, Mr. Ray, we have 4 sig figs. Our final answer should have 4. But remember, this is subtraction, so we can only have 1 past the decimal. When you get in your calculator, you're going to get 720.9. Well, since you can only have 1 past the decimal, that is our final answer. Is 720 millimeters of mercury. All right, let me know if you have any questions, and best of luck.